So this problem is asking for what is the average power in a single phase AC circuit with a purely inductive load. Now it also kind of says this last part. For sinusoidal steady state excitation, it's all that really matters is we're looking for the average power in this AC circuit. So I've gone ahead and drawn that AC circuit, and it's just going to be an alternating AC voltage source. And then we have just an inductor connected to the positive and negative side of that. So to actually find the average power, let's remind ourselves that P power, the real power, is going to be the real part of the voltage multiplied by the current. And what is the current but the voltage divided by the impedance? So I'm going to say that since I equals V over Z, we have V squared up top, and I'm writing that as a phasor with V max as the magnitude and 0 as the angle squared. And then we have the impedance on the bottom. So let's go a little bit further with that. And let's remind ourselves that the impedance in this circuit, there's no real part to it. There's no resistive part to it. So the first term is going to be 0. And then the reactive part of that is going to be omega times the inductance L. And we get that here from the inductive reactance is equal to omega times L, the inductance. Now if we work that a bit further, we can convert that rectangular form to a phasor form. So we get omega times L, the inductance, with an angle of 90 degrees. Now if we go a little bit further with that and we actually divide these phasors, we subtract 90 from 0 to get minus 90 degrees. And that's because this phasor is divided by this phasor. So we'll take their magnitudes and divide them here, and then we'll take their angles and subtract 90, the bottom, from 0, the top. To work this one a little bit further, we will expand the phasor form of this to the Euler expansion of it. And so now we have the real P average equals the real part of the magnitude times cosine of minus 90 plus j sine of minus 90. Now, to simplify these terms, we'll just say cosine of minus 90. If we put that in our calculator or look at it on a diagram, that's going to be 0. And then j sine of minus 90 is going to be minus 1. And then we keep our j there. So the real part of this, remember this is just the magnitude, so you'll multiply this through. The real part of this is actually just 0. So P average is going to work out to be 0, and the answer is C. This may seem counterintuitive, but all this is really saying is that this circuit only uses reactive power and it does not use real power.